Let's take a look at the difference between a carboxylic acid and an ester. So we're talking about the functional group, the carboxylic acid functional group, and then the ester as a functional group. So here's the general form. You have this carbonyl group. Both of them have a carbonyl group in the center, and both of them are bonded to the rest of the molecule. And both of them have a single bond to an oxygen. So that's the same as well. So they're very close. The only thing that's different is that for the carboxylic acid, we have this H here. The oxygen's bonded to a hydrogen. For the ester, the oxygen is bonded to a carbon or a chain of carbons. That's the big difference. So for the carboxylic acid, when you see that hydrogen bonded to the oxygen that's bonded to the carbonyl group, that's your carboxylic acid. So let's try some. So these are the same structure, just different representations. Is this a carboxylic acid or an ester? Pause, give it a try. So we have this carbonyl group, and that's present in both of these. Then we have this carbon here. That's the rest of the molecule. That's the same. So we're looking here to this right here, that hydrogen. That tells us we have a carboxylic acid, because here it would be a carbon if it was an ester. We could even look at this in 3D. We have our double bonded oxygen. We have our carbon here with hydrogens around it, and there's that OH group on the end. That makes it a carboxylic acid. So give this a try. We have a structural formula, and here's the molecular model. Is it a carboxylic acid or an ester? Pause, give it a try. So this is the rest of the molecule. These are carbons here. That's the same. Double bonded oxygen with this oxygen single bonded. That's the same. What's different is at the end, we have the rest of the molecule here. That's the carbons. So it ends with these carbons after the oxygen. That means it's going to be an ester. Let's try another one. So pause. Is this an ester or a carboxylic acid? So this one's a bit of a trick. We have our double bonded oxygen here, and we have that OH group here. So we see all of this is the same. So it's looking like a carboxylic acid because it ends in the hydrogen here on the oxygen. But we have a hydrogen. This is a special case. It's the simplest carboxylic acid, and it does end in a hydrogen here, but we still call it a carboxylic acid. Let's try another one. Is this a carboxylic acid or an ester? So we have our double bonded oxygen, oxygen here bonded to a carbon, so it doesn't end in the hydrogen, it ends in this carbon, right? Here's the rest of the molecule. That means this is an ester. And this is another case where it's the simplest ester that we have, so it does end in H here. We're considering that the rest of the molecule. Bit of an exception, good to know. Let's try one last one. Ester or carboxylic acid? So right here's the rest of the molecule, all of this. Then we have our double bonded carbon, our carbonyl group, and the oxygen. And then right here, we have these carbons, the rest of the molecule here. That's going to be an ester. If it ended in H right here, then it would be a carboxylic acid. Actually, one more. Let's try this. Kind of a long one here. Ester or carboxylic acid? Give it a try. So here are all of these carbons here. Remember, each carbon's bonded to 4 things, so we'd have a bunch of hydrogens around them. That's the rest of the molecule right here. Then we have our double bonded oxygen, single bonded oxygen to a hydrogen. There it is, carboxylic acid. That's it. This is Dr. B looking at the difference between carboxylic acids and esters. Thanks for watching.